All right, this is actually the the work that actually go with lesson P1, which is dealing with real numbers. By now, you should have already watched the video for P1 dealing with real numbers as it pertains to the notes and got the PowerPoint notes. Now we're going to actually start working with some problems. The first thing we're going to do is examining the decimal forms of rational numbers. In this particular problem, you're going to find the decimal form for the rational number, and then you're going to state whether it repeats or terminates. Problem number one, or example number one, is actually problem number three in your textbook. Here we have problem negative 13 over 6, and we want to determine whether this is a terminated or repeating decimal. So if you use your calculator and take the negative 13 and divide it by 6, you should come up with negative 2.16 with the 6 repeating. Therefore, this is a repeating decimal. This is a repeating decimal. Example number two happens to be problem number 5 in your book. In example number 2, you're going to interpret the inequality that you see. X is less than or equal to 2. Here, your goal is to describe and graph the interval of real numbers. X is less than or equal to 2. This represents all real numbers less than or equal to 2. That's how you would describe it in words. If you're going to graph this, draw my number line. Please denote where the 0 is on your number line. You don't have to put a lot of points on there, but you at least have to represent the end point that's in your particular problem. And here, based on the inequality symbol, and as you've seen in your notes, this will have a brace at 2, and it will be shaded to the left, representing less than. Example 3. Example 3 happens to be problem 15 in your book. In this problem, you're going to write the inequality for the words that are given. So in this particular example, you're going to use the inequality to describe the interval of real numbers. Example 3 states that x is between -1 and 2. So the inequality for this, based on the words that you have in problem number 15, would be -1 is less than x, which is less than 2. This is the corresponding inequality to what corresponds to the words that you have here. Example number 4 happens to be problem 29 in your book. Example number 4 happens to be problem number 29 in your book. Example number 4 asks for you to convert the inequality notation, or convert my interval notation to my inequality notation. And then you're going to find the endpoints and state whether the interval is bounded or unbounded and is tight. So in example number 4, we have parentheses -3, comma 4 brace. So to write this as an inequality, because there is a parentheses here and there is a brace here, this lets me know that my inequality should be written with a less than symbol because of the parentheses. You can use any variable. I'm going to use the variable x, less than or equal to 4. This happens to be my inequality. So I just transferred from interval notation to inequality notation. The second part they ask you in problem 29 is to describe whether or not it is bounded or unbounded and is tight. In our case, in problem number 29, negative 3 and 4 are as endpoints. Is considered to be bounded and half open. It's bounded on the endpoint 4 and it's open going towards negative 3. That means it continues on without bound. So that's problem number 29. Problem number 5. Use the distributive property. Problem number 5 happens to be number 37 in your textbook. In this particular problem, or in this particular section of questions, it says use the distributive property to write the factor form or the expanded form of the given expression. Here we're giving you a times x squared plus b. So using the distributive property means multiply these two expressions together. A times x squared gives me ax squared plus a times b. And this happens to be your expanded form for the distributive property problem that you have. Problem number 6. Problem number 6 happens to be number 43 in your textbook. It corresponds to number 43 in your textbook. Problem number 6, we're identifying the base. So this problem happens to be negative 5 squared. So whenever you look at this particular type of problem, sometimes students get confused and say, well, the base is negative 5. But because this thing is not in parentheses, this really means negative 1 times 5 squared. And in all actuality, my base happens to be 5. So the correct answer for the base for problem number 6 happens to be 5. Problem number 7. Problem number 7 happens to be problem number 47 in your textbook. You're going to simplify expressions involving powers. Simplify expressions involving powers. So in this particular problem, you're going to actually have to look at your notes on exponents. So I have x raised to the 4th times y raised to the 3rd divided by x squared times y raised to the 5th. So if you look at this as not just one whole problem, but break it down, I have the same base on the top and the bottom. And according to your powers dealing with exponents, if you have the same base on the top and the bottom, your goal is to subtract your two exponents. So normally what I do when I look at problems like this, because the larger of the two exponents occur on the top, that means your final answer, that particular variable should be on the top or in my numerator. Now, I look at my y values. The 5 is larger than the 3, so it's going to end up on the bottom. So really I have x raised to the 4 minus 2 and y divided by y raised to the 5 minus 3. And from here we're going to simplify this expression as x squared divided by y squared. And that's your solution. So if you take a real good look at this problem, if you have any questions, make sure you bring those questions to class tomorrow. That is a basic exponential problem. All right, problem number 8. Example number 8 happens to be problem number 57 in your textbook. So your goal here is to convert to and from scientific notation. So in problem number 57, it asks you to write the number in scientific notation. And it says the mean distance from Jupiter to the sun is approximately or is about 483,900,000 miles. So your goal is to write this number in scientific notation. So when you was looking at your notes, there was a couple of things that you should have paid attention to. All numbers in scientific notation, the first number in front of the decimal has to be a number between the numbers 1 and 9. Excuse me, 1 and 10. It can't be a two-digit number. So what I'm actually going to do here is do something that you've probably seen before. Count my decimal places. And as I go through, I actually have 1, 2, 3, 4, 5, 6, 7, 8 numbers behind that decimal, and it actually will represent my exponent. So as I write this number, I cannot lose any digits that's considered to be significant numbers or significant digits. So I have 4.839, and then after that, I don't really have to care about the zero that's after the 9 because it's not significant. 4.839 times 10 raised to the 1, 2, 3, 4, 5, 6, 7, 8th power. So now we just converted a number to scientific notation. And it's problem number 8. Again, is example number 57 in your book. Problem number 9, or example number 9, happens to be problem number 59 in your book. Problem number 59 in your book. You're going to write the number in decimal form. So in problem number 59, you're given a number 3.33 times 10 to the negative 8 power. So your goal, again, is to write this in decimal form. So if you take a look at problem 59 real closely, what we're going to do is write it out in expanded form. So actually what I have is, and I'm going to slide this over so you're going to actually see this. When the exponent is negative, that means you actually go to the left. So as I loop this, I'm actually going to go 1, 2, 3, 4, 5, 6, 7, and 8. And then I'm going to stop and put a decimal point. And in each one of those cradles, you're going to actually fill it in. And as I fill that in, that will represent the number of zeros that I have to have. And if you count it up, you actually should have 7 zeros. And because of the position that 3 in, it represents the negative 8. So your particular answer for this problem will be decimal 1, 2, 3, 4, 5, 6, 7 zeros, and then 3, 3, 3. That's using scientific notation. Last problem. Problem number 10. Happens to be problem number 63. And it pretty much goes in the same line of using scientific notation. Problem number 63, or example number 10, asks you to use scientific notation to simplify this. So I have 1.3 times 10 to the negative 7 power times 2.4 times 10 to the 8 power divided by 1.3 times 10 to the 9th power. You have to simplify this without actually using the calculator. Well, since that's the case, there are certain things that you have to understand. Again, exponent wise, you actually have 1.3 times 10 to the negative 7 on the top, and you have a 1.3 times 10 to the negative 7 on the bottom. So when you're looking at problem 63, one of the things that you got to pay attention to is this. You actually have the same base, so what you can actually do number wise is multiply 1.3 times 2.4 together. So again, you have to do this particular problem without a calculator. And then don't forget